Hi everyone, welcome back to my YouTube channel. In today's video, I'm going to be going over LeetCode 79, which is known as the word search problem. The difficulty of this problem is medium. Alright, so we're given an m by n grid of characters board and a string of board. We have to return true if the word exists in the grid. The word can be constructed from letters of sequentially adjacent cells where adjacent cells are horizontally or vertically neighboring, and the same letter cell may not be used more than once. Okay, so we want to consider, for example, cell F or cell that contains letter F. So the neighbors of this cell is going to be B, C, D, and S. And for example, if we are to consider the first cell here, which contains character A, that means the neighbors of this cell is going to be S and B. Okay, so let's just go ahead and check out how we can approach this problem. Now, imagine if we are given the word A. So the very first thing we want to check here is to check if this character here, which is A, is on this board. Well, that is true. If we have to look at the first cell here, that's true. And then we can return true because there is no more character left here to check from this word. Now imagine if I give you, or if we have to check if AB exists on the board. Now the very first thing we want to check is first character here, which is A. So if the first character exists on the board, then we then proceed to check the next character here, which is B. Now we can only check the next character based on the neighbors of A. Now neighbors of A here is either S or B. Now if we check S, so S is not equal to B, that means we also need to check the other neighbors, which is B. Now the next cell, which is this cell here, corresponds to this character here, which is B. So that means this is going to be a valid path, which is this is going to return true, and then this is also going to return true, and that's all. Now imagine if I give you this word. Take for example A, B, C, and Z. Okay, so the very first thing again we want to check is that we want to check if this first character exists on the board. Well, that is true because this is the first cell contains the first character. Now, we are not done checking. Since we have the first character to be contained on the board, then we then go ahead and check the neighbors of that cell to check to see if the next character here, which is a B, because we haven't exhausted all the characters on the word or from the word. Now the next character here is a B. Now we are starting with A. Then what are the neighbors of A? Neighbors of A are S and B. Now we can go through this part because S is not B. We can only go through this part, which is a B, which is correct. Okay. Now we haven't exhausted yet all the characters from the set. We want to check the next character here is a C. Now we want to check the neighbors of B. Now neighbors of B would be A, C, and F. Now we can check A because A is already visited, so we can mark this visited. And then we go ahead and check the possible characters we want to check is going to be F or C. Now, if we check, go through F, part F. Now, F is not C, that means we don't want to go through this part. We only want to go, we can check the next part. Now, next part here is going to be A, C. Now, which corresponds to what we have here. So that means this is going to be a valid part up to this point. Now, we are not done. We haven't exhausted all the characters from this word. So what we want to do next is to check the next character, which is Z. The next character we should be checking from as part of this neighbor should be a Z. If we check this down here, this is not a Z. And if we check this right here, this is not a Z because this is a E. Now, since we are here and the next neighbor or the next character here is Z, and then we cannot find Z as part of the neighbors of C, that means we can just return false, and then we remove this character here that is being visited. We can remove it from the visited set. We can remove this from the visited set, remove this from the visited set, and consider this part here invalid. All right. So once we can do that, that means the first character we considered is not valid. So that means that we have already visited this part here. Then we can then go ahead and check the next cell. Okay, we can check the next cell to see if that could be a possible starting point. Well, this is not a possible starting point. This is not a possible starting point. Then we can go all the way here. Okay, this is not a possible starting point. Okay, so again, we find a possible starting point from this cell, which is A. Okay, because it's on the board. Then we want to check the neighbors of A, which is going to be S or D. Now, neighbors of A in this case is a B, or the character we are checking for is a B. But then the neighbors of A are either S and D, and we cannot go through this part. And we also haven't exhausted all the characters from this word. That means that this is going to be a false. Then we can just return false, and that's all. All right, so let's just go ahead and start translating what we describe as a Python code. So since we are dealing with a grid, the very first thing we want to do is to get the number of rows and also get the number of columns. So I can just say rows here should be length of the board, and then number of columns here is going to be length of the board at one of the elements. So here again, if we look at how our data was given, so length of the board itself would correspond to the rows, but then one of the elements here is going to, if I should take the length of this first element here, that will give me length of the columns, because we have length of this element to be equal to all other elements on the board. Okay, so next thing we want to do is to loop through to check if the first character here is on the board. The first character here is A. We want to check if it's on the board. So to do that, we can just say for rows in range of the rows here, and for C in range of columns. So what do we want to check? We want to check if the board row and at C would correspond to the first character. So we want to check if this is word at 0. Now, let's say that is true. Let's first take that as a pass. Okay. Now, let's say, imagine I give you the word Z. Let's say what I give you here is a Z. So I can just comment this. So I give you a word, which is, for example, I'm looking at just Z. Now, if Z, obviously Z is not on the board. So you can check the first element here, because this double for loop just loop through all the rows and columns on this board. If I should loop through all the rows and columns on this board and I did not find a Z, I can just return false. So let's imagine that what the word we are given is AB, for example. So that means that we are able to find the first character on the board, and we haven't exhausted all the characters from this word. So what we want to check is to see if the neighbors of the cell we are starting with, which is this cell here, would contain this neighbor B, or would contain the next character, which is a B from the word. So to do that, we want to check if this is true, if this part is valid. So we are going to be using a DFS here because we want to consider all the possible parts, DFS. So my DFS is going to contain 3 things: my rows, my columns, and the index. So the index here shows that I am currently looking at the first character. Okay. So now if this is true, then I can just return true. So if this condition here is true, then I can just return true. Now imagine that we are starting with the first character, or we only given just one character, which is A. Now this is going to be DFS at 0. So I want to check my DFS at 0. Again, I can just go ahead and start writing my DFS function. So I can just say def DFS, which would take three information: my rows and my columns and my index. So again, we want to check. This is our starting point. This line of code here is to check if our starting point is on, or if we could find a valid starting point on this board. That's the meaning of this line of this code. Then the line of this code is to now check if the word, if we start from this point, can we exhaust all the characters from this word? That's the line, this line here. If we can do that, that means this is going to return true. And then that means that this is going to return true globally. Okay, so that's what we want to do here. Now we want to dep this DFS function. We want to define this DFS function. And how do we define it? We want to define it recursively. So to define it recursively, we need some base cases. So the very first base cases we want to consider here is if the board at the row and at the column is not equals to the word at I. So what is this saying? For example, if I give you the word A, Z, let's say we are starting with this first row here, because this is going to be our valid starting point, because the first character from the word is A. And then we go ahead and check the neighbors of A. Neighbors of A is either S or a B. But then we want a Z, which is not part of the neighbors of A. So that means that this is not a valid starting point. This is just going to return false. So this is going to return a false here, meaning that this is not a valid. This is not a valid path. And since this is not a valid path, then that means it will now go ahead and check again. To go ahead and check again if I already exhausted, of course, because I have to consider all the elements. I have to consider all the cells here to see if this is a valid starting point. Imagine if I'm given AD, for example. Obviously, the word AD exists on the board. But then if I'm starting with this cell here, this is going to return. This is not a valid path if I'm to start with this first cell here, because obviously this would, as a result of my double for loop, it would discover A first at this point. But then the cell here, or the neighbors of the cell here, is either S or a B, which is not part of, or which is not going to contain a D. So that means that this cell is done. We are done with this cell. So this is going to return a false here. So since this is returning a false, that means that it will have to go through the next cycle of to check the first character, checking all the first character. So since this is not a valid starting point, this is not a valid starting point, this is not a valid starting point, this is a valid starting point. The last row, first column, is a valid starting point. Then it will check the neighbors. Since I haven't exhausted all the characters from this word, then it will check what are the neighbors of S. Neighbors of A are S and D. Now, since neighbors of A are S and D, that means that I'm going to check the neighbors of A. So neighbors of A contains a D. That means this is a valid starting point. Then it's going to return a true. So what I want to do in the next base case is to check if my index I is the length of the word minus 1. Length of the word minus 1. Okay, this is just to check if I already exhausted all the characters from this word. So if I exhausted all the characters of the word, I can just return true. So in a case whereby I haven't exhausted all the characters from the word and this condition is false, and then also this condition is false, then I can just mark this visited. So to mark it visited, I'm going to define my visited as a set. Now, again, we are currently, for example, we are currently at the starting point. So because we want to mark, for example, if we are given the word A, B, C, if we are starting from here, A, the neighbors of A contains the next character, which is a B. Neighbors of B are A and C. So I do not want to go back to A. So that means I want to mark this visited. So since this is already visited, that means that I can only visit F and C. So neighbors of C would be B, or once I visit a B, neighbors of C would be B, C, and AE. Now, since we already visit B, that means we can only visit E and C. So that's how it works. Okay, so we can, once we are done with that and we haven't exhausted all the characters from the word, so we can just visit dot add. So what do we want to add? We want to add the current rows and current columns. Okay, so once we visit that, then we now want to go ahead and check for the neighbors. So to check for the neighbors, we can just say for dr dc in this list here, list of tuples. So let's imagine I'm at the first row, first column. That means I can either go to the front or I can go backward, which is going to be 0, -1. Or I can go up, which is going to be 0, comma, or -1, comma 0. Or I can go down, which is going to be 1, comma 0. Okay, so if that is the case, then I can just check out the neighbors, which is NRNC. So my neighbors is going to be my current role plus my DR and my current column plus DC. So once I check that out, again, think about it. If my R is 0, 0, then the possible NR, NC, or the possible neighbors of my rows and columns would be all these tuples here. Okay, but then 0, -1 means cell to the left of A, while -1, 0 means cell that is above A. We don't want to consider that because that will be outside the bound of the cell we are looking at. So what we can do is to eliminate that. So to eliminate that, we want to check if this, we want to check this condition. If my NR is less or equals to, or let's say if 0 is less or equals to my NR, that's if it's greater or equals to 0, and if it's less than rows. Okay, so because we already calculate the length of the rows, which is stored as rows. So again, because Python started counting at 0, so that's why we are using strictly less here. And then we also want to check if 0 is less or equals to my NC, strictly less than number of columns. So if that is the case, then we want to check if these neighbor nodes, NR and NC, if it is visited, not in visit. So if it is not visited, we can then go ahead and visit it. So what does it mean to visit it? So we want to check if my DFS at the rows and at the columns. So now this is going to be NR and then NC. Again, we are currently visiting or we want to check if this is a valid path. So imagine if we are starting with the first character is A. We want to check the next character. Next character should be I plus 1. And then we are checking it based on the neighbors of A. So we are checking it based on the neighbors of the first character, which is NR, NC, but then it has to be I plus 1. Then if this is true, then we can return true, or else we can just mark this visited. So again, if this is false, for example, if we try to proceed to either A or B, if we try to, let's take for example, we are given AZ. Let's say the word we are given is AZ. Okay. The next character we want to check is to check if this is AZ. But then this is the neighbors of A here is S and B. So that means that this is not going to be true. This line is false. Okay. So since that line is false, that means we can just remove it from visited. So we can do visited dot remove dot remove. We can just remove that current row and column we are looking at. So that means that this part is not going to be valid. So we can go ahead and remove this previous part here, which is removing this part here from the visited cell, so that we can use it for the all other things we want to use it for. Okay, so and then that's pretty much it. So let's go ahead and check and submit our solution to see if this is going to run. Okay, so we have it to be accepted. So let's go ahead and submit this. All right, so that is correct. Okay, so let's try to analyze the time complexity of this, time and space complexity of this. So what is going to be the time complexity? So time complexity of this is, now we have a for loop here. That means we are doing M operations because we have M rows. And then we also have number of columns here, which is N. That means because we have N columns, that means here, this is N by N. And then because we have to go through all the, now if we have to do our DFS at this point, and our DFS contains another for loop, which here we have we have to check for directions, and we have to check it for how many words. So basically the length of the words. So that means the worst case complexity here is going to be m multiplied by n multiplied by 4 to the power of l. And then how about the space complexity? So the space complexity in this case is going to be, now where do we need to store things? Well, we really need to store, the worst case here is going to be the visited set. Now, because we have to visit each and every one of them, so the worst case would be L minus 1, okay? Because we would not eventually mark the last one visited. So we would only at worst visit L minus 1, which is still going to be L. So the worst case space here is going to be L. So that's all. Thank you so much for watching this video. I hope you gained something. I hope you learned something new. All right, if you enjoy my video, please click on the subscribe button. That's the only way you can support me. Thank you so much for watching. I'll see you next time.